Just go whatever you want to do. I'm with you.
My calculator. Good afternoon. Hello. Get her number and call her later this afternoon. How's everybody this afternoon? My name is Lieutenant Vitale, and I'm from your friendly Plainfield Fire Department. Yeah, we give classes to all new employees and students quite frequently here. We've been doing it a long time, 25, 30 years. To get you familiar about our end of the spectrum if there's an emergency. And it also familiarizes you with your end of it before we get here. Our class is going to be on electricity this afternoon. Something everyone takes for granted and doesn't really realize the dangers of it. One mistake could cost you your life. It's that easy and that fast. There's two types of electricities. You have AC, which alternating current, and DC, direct current. The DC is like your car. It's one continuous circle. Your alternator charges, it goes through your car, into your battery, out your battery, right into your alternator again. It's one way. By the way, if you ever work on your car, always disconnect it at the ground wire, and you won't get shocked or anything, especially if you put it in a starter or something. That's a good tip. And never wear any jewelry. The alternator current is what most of us live with, at work and at home. I could put these lights on that switch, and turn them off on that, or vice versa. It doesn't matter. The current goes either way, whatever switch calls for it. I'm just going to briefly tell you how it works. The current comes into your home off the pole, 220. Everybody has a 220 line going from your home. But it's broken at the meter to go into your home as a 110. That's what this country is using, 110. You ever notice people going overseas, they bring an electric shaver or curler, they can't use it, they're all on 220. But this country has 110. After it goes into your home, it goes into a breaker or a fuse box. Today, they use the breakers. The breaker is just a safety device. If something happens in that line, something shorts, the breaker is supposed to trip so the wire doesn't overheat, or the unit that's shorted is overheat and cause a fire. The old ways, which we still see a lot of in this town, is they use fuses. Has anybody ever seen the glass fuses? Does anybody know what I'm talking about? There's a link in there. And when something shorts out, instead of throwing the breaker like the new system, the link melts. And it stops the electricity from continuing back into that unit that has shorted. Now, a lot of the old homes were built in the early 1900s in this town, and they were wired, and keep this in mind, for the convenience of what they had in the 20s. Remember, they didn't have television, they didn't have dishwashers, they didn't have washing machines, they didn't have clothes dryers, they didn't have microwaves. All this is putting a load on those wires. The older wire has cloth over it as insulation. The new ones today have plastic over it, And some of them, they use BX cable, like commercial buildings, there's metal over the wire. This keeps the wire from chaffing or breaking or fraying. And I like the metal because you're not going to find it in residential because of the cost factor, but rodents are a problem sometimes, chewing on wires and the walls and everything. And with the metal, they can't do that. A lot of shortcuts people do that are fire hazards, that if you see, you should get rid of. A lot of the older homes, their only breaker that should be in there should be a 15 or 20 amp. But what happens, like I said, with all these new appliances, they start breaking the fuse throws away, they put another fuse in, it throws away, and then after 6 times in one day, the guy should learn, hey, guess what? I have too much stuff on this load. They don't do that. They go out and buy 25 amp fuses to carry the load. And what's happening now is the wire is getting overheated from everything, but it can't throw the fuse because he went from what he's supposed to have in there, 15 or 20, into a 25. And that works. But it's also a fire hazard. And when we see them in older homes, we give them violations to get them out of there. Some of the tricks that people have used very carelessly is even when the 25 breaks, they used to take pennies and put it in there. Penny is copper. It will keep the current going through the house. The penny will be in there, but the house will be burned to the ground, I guarantee you. It works that way. In a commercial building, they use these large fuses. They're like 3 inches long and a half an inch wide. And they put the fuses in there, and they get these real heavy-duty machines they use for pressing and everything. I'm sure you're familiar with them if you ever been to a big factory. You can just think of the amount of electricity one unit uses. Well, in the old days, they used to take copper pipes, copper again, and put it in the fuse. Then the breaker is defaulting. Like I said, the factory burned down, but the fuse will still be in there, their homemade fuse. That's a violation, too. So there's things at home that you want to look at. You want to keep your amperage really low on the fuses. 15 is normal. And if you've had your house rewired, I strongly suggest that you go to the breaker system. The wires are heavier, and they can take a lot. Okay, we're talking about your appliances at home using a lot of electricity. Think about just what this hospital uses. You have computers, how many of them? A couple hundred? A few thousand typewriters, copying machines, everything here. It's a very heavy load. All these units, you'll see they have 2 prongs and a little round prong on the bottom. That round prong is the most important prong, believe it or not. That's your ground. That's your ground to the machine. If something happens to the machine, it'll short out that wire on the ground wall. So one thing you don't want to use, now they're going to show you in this movie how a man is working in the shop. He had an extension cord, which wasn't heavy enough to begin with. They'll stress that. 2-prong. His tool was a 3-prong. He bends the ground wire, puts the 2 prongs into the extension cord. Now, I'm sure everybody's done that. That is how you get electrocuted, especially if you're by water. The one they didn't show, which is a biggie, is, did you ever see that little gray adapter that goes 3 to 2? Okay, how many of you take that gray adapter, plug the 3 into, and just put the adapter in the wall and it's working? It's not working right. I'm going to tell you how that's supposed to be. That's something that is shown in the film that I came up with. See this screw right here on the plate? That wire is the ground wire from your appliance. It's 3 to 2, but you're not finishing the connection. That little wire is supposed to be plugged into the screw on your box. Now you've just finished your ground. A lot of people, they carry them in their pockets, they use them. They're really supposed to be, the best way is to just leave them in the wall if you're going to use that. I'll tell you, if you have to use it all the time, you should have your system changed. Have the ground wire all put in. Because like I said, years ago, they didn't have that kind of stuff. Your house might be an older house, but if you're going to...
So I can't rewire it.
Oh, but if you're using that, the best thing is update the system. But you're not supposed to take the unit, put it in a 2 or 3 pronger, and just come out with 2. The third prong, like I said, is that wire. It's supposed to be grounded. What happens, the screw is grounded to the box is grounded to the whole system. And there's 2 ways they ground the system out. The old way is they connect the main ground wire from the box to your sewer line, which is usually cast iron. So if you get hit by lightning or something, or you have a problem, it's grounded out of the house. The other way today, if you have a new service, and up where I live, we don't have sewers, we have septic, they drive a 6-foot copper pole right into the ground. That's my ground for my house, is this copper line goes right into the earth. And we're talking about grounding out, which is really what is, at a fail-safe, a unit. You shouldn't really have any of your appliances on to an electric store. I mean, it just makes sense if there's going to be lightning anywhere, what it's going to do. Your house is going to be the ground. And everything you have plugged in, it don't even have to be on, is also going to be the ground. So you can just count on losing your VCR, your microwave, your TV, and everything you have plugged in as out. It's dead. Yes.
How about those, they call them surge protectors, the long strips that they reload?
Oh yeah, they have that net. I didn't want to get into that, but most systems don't have that. Most systems just like I said, alternating current in and out of the house, but that's a good thing to have. They also put lightning rods up. What are the rods? Piece of wire all the way down the side of the house. You know what they are, the lightning rods, the big thing sticking up, usually people put them on the chimney. It's grounded right into a pole into the ground. So, but my a suggestion, if you want to save yourself a lot of heartache and a lot of paperwork, is don't have anything plugged into a lightning storm. That's the best way to do it. And there's been people, even I've read in the paper, and I'm sure you have, using the telephone, house got hit. It's electric, not much when it's safe, but you're just acting as a ground when you're holding that receiver. So it's just little things. Like I said, we use electricity every day, and no one's really afraid of it no more. They just take it for granted it's going to work, and it's fail-safe. Nothing's fail-safe. Does anybody have any questions to this point about anything I've said? Yes, ma'am.
Did I understand you say during a storm you should unplug every electrical appliance in your home?
You have a chance of losing every one of them. Mainly the big ones, the TV, the microwave, things like that. Because if lightning hits, everything that's in that wall socket you're going to lose. It's going to short out if it hits.
It will burn the appliance?
It will shorten out the appliance. What you're doing is your house has become the ground of that lightning. It hits the house. It has to go all the way through the house before it goes to the ground. So everything in its way, and it will instantly find every outlet, everything plugged in. But the TV's a big one, really. That's another thing. While the TV's plugged in, we didn't have too much a problem years ago with color TV. Well, excuse me, with the black and white TV. But with the color TV, even when your TV's off, you're having current going into the TV. Even when it's off, there is current. Your set's off, but the current's still coming into the TV. Have all of you had your triangular fire, how it works? What do you need? Oxygen, heat, and fuel. Something's wrong with the TV, you're fueling it when it's plugged in. The current's still coming in there. Whatever you have burning in there is getting going short, and you're just feeding it more and more. So it just makes sense. The safest way is just to keep it unplugged when you're not home where you're sleeping. And you know how things are made today. The cheapest, fastest way they can make them. If you ever look inside the TV, it's very dusty, very dirty. It just makes sense, that you What you want to do is what we do in our fire prevention system. You want to prevent it before it starts. So I'm going to play a film for you. It's very good. Please take any notes if you want about any questions on the film.
110 million volts lights up the sky. 110 volts lights up a room. We all know that lightning can kill, but too many of us forget that the low voltage source that comes out of a typical household outlet like this can kill too, if you neglect to follow simple safety rules. You're about to learn how electrical hazards can cause fires, burns, shock, and other injuries, and the steps you can take to protect yourself and others from harm. But first, we're going to take a very simplified look at how electricity travels, because that's where the dangers lie. We all know that electricity and water don't mix, but the flow of water provides a good illustration for how electricity travels. It flows through a wire like water flows through this hose. Pressure pushes water through a hose, and likewise pressure, better known as voltage, pushes electricity through its wire. When the water reaches the end of the hose where the nozzle is located, it must wait for the nozzle to open in order for it to flow out. Likewise, once the electricity reaches its destination, the switch, it waits for the signal to allow it to power the appliance or equipment. Direct electrical current only flows in one direction. However, more common is alternating current, which flows in both directions. Either type can be hazardous to you if it leaks from its path. Why? When the insulation around the wire frays, cracks, or breaks, or a connection is faulty, electricity can leak out or find another path. This is known as a short circuit. If you touch any part of the damaged circuit, the wire, or any part of the electrical equipment, you become a part of the circuit. That's when you receive a shock. An electrical shock in the movies raises a few hairs and a few laughs, but in real life, an electrical shock can be deadly, and there's nothing funny about that. You'll learn what factors make you most susceptible to receiving a shock later on. For now, though, it's safe to say that electricity is something to be respected, not feared. Always assume that the potential for electric shock is present and take the necessary precautions to prevent it. The following 8 guidelines will help you work safely with or near electrical equipment. The first guideline is to inspect your work area for electrical hazards daily. What should you look for? Flickering lights, sparking or smoking at receptacles, switches that are warm to the touch, the odor of something burning, loose connections. Take care of equipment, because improper handling and poor maintenance can pose deadly electrical safety hazards.
What's that smell? Something is burning.
I guess the machine's running hot.
Running hot. It smells to me like something's melting. If I were you, I'd shut it down right now and call maintenance.
Whoa, oh, you're right. Look, stay right here. I'm going to go make the call. First, I've got to shut it down.
If you detect an electrical problem, follow your company's procedure for reporting it right away. Never ignore an electrical problem. Failure to take prompt action could result in a fire or injury, which brings us to our next point. It's always important to choose the proper electrical cords and connectors for the job. By doing this, you won't be risking your safety by altering electrical equipment in any way.
Now, where's that heavy-duty extension
No, I
cord?
was telling you about the ground.
Well, I'll just use this one and bend the grounding prong out of the way. It'll do for now. There. This is just a quick job.
Rich made 2 serious electrical mistakes. First, he bent the grounding prong on the plug so it would fit the extension cord. Grounded plugs with 3 prongs are designed with safety in mind. The purpose of the 3rd prong is to provide a path for stray current to ground. Always ground electrical tools and equipment. Never modify a plug by bending or removing any of the blades. And never use a plug if the housing is damaged or the insulating device is removed. The second mistake Rich made was to use the wrong type of extension cord. There is a right extension cord for every job. Consider the equipment, its power requirements, the environment, and the cord's wire thickness and length. A good rule of thumb is to make sure that the extension cord's thickness is at least as thick as the equipment's cord. Be sure to take proper care of all electrical cords. Damaged cords cause thousands of electrical fires and injuries every year.
Hey, hold on there. Take it easy with that cord. Look, I'm in a hurry, okay? So skip the lecture. Don't you know you can damage the cord by yanking it out like that? You can even start a fire. What's your problem today, anyway? Hey, what's with you? Look, this one's really frayed. Looks like you yanked it one too many times. Better tag it for repairs before someone gets hurt.
I guess you're right. I should be more careful.
The only thing Bob did right was to remove the cord from the outlet when he was finished. But the manner in which he did it was all wrong. You must turn off equipment before you pull the plug. And don't yank on the cord, grasp the plug instead. Then gently rewind cords to prevent the interior wire strands from breaking. Now let's look at the next rule, which is one of the best ways to prevent electrical hazards. Read and follow instructions for proper use.
Ugh, this'll take forever.
Hey, Marge, how you like the new office?
Great. I just wish they'd hurry and set up this computer. I've got a ton of work to do.
Oh, good luck. I'll see you later.
Yeah, Joe. I'll see you later. What am I waiting for? I could set this thing up myself. No! I got a shock when I tried to plug it in. Well, why didn't you wait for engineering to set it up? I figured I could do it. Well, did you follow the instructions in the manual? Well, not really. I just plugged it in. Look, any attempt to set up and operate any electrical equipment without reading and following all the instructions could result in an electrical shock. And in this case, you might have damaged the hard disk drive as well.
This rule applies at home as well. How many of you have attempted to set up and operate or repair an appliance without reading the instructions? It's a common violation of electrical safety rules. You should always read and follow operating instructions before you use any electrical equipment. And be sure to get professional advice if you have any questions. Which brings us to our next point. Leave equipment repairs and adjustments to authorized personnel. Don't tamper with or try to install electrical devices or equipment. Notify the appropriate personnel and leave adjustments to them.
Hi, Bill. This is Doris. There's a problem with the outlet next to my machine. You think you can come down and take a look at it?
In the meantime, prevent others from receiving a shock. Warn them that there is a problem. This brings us to our next point. Follow required lockout-tagout procedures.
I don't know. It's making this grinding sound and then it just stops.
I better take a look at it. First, I'll have to lock and tag it out.
What is lockout-tagout? When you're blocking the flow of energy from the power source to the equipment and keeping it blocked, that's lockout. Tagout means placing a tag on the power source to warn others not to turn the power on. It's always necessary to lock out, tag out to prevent the accidental startup of electrical equipment. The first step in a lockout, tag out procedure is to turn off the equipment and disconnect the energy source. Use a lock to prevent the flow of energy from being restored. Test to make sure it can't be put in the on position. Even though you're using a lock, it's also important to place a tag telling others who you are and what you're doing. Release stored energy that could cause sudden movement. Test it again to make sure no power is getting to the machine before working on it. When you've finished working, check to make sure all tools have been removed, all lines have been reconnected or unblocked, all guards have been replaced, and other workers are safely out of the way before removing your lock and tag and turning the machine on. Let's take a look now at another way you can protect yourself. Always use the appropriate protective equipment.
As an electrician, I know the dangers of electricity. That's why I never wear rings or other jewelry on the job. Because the metal can conduct electricity. And I always use personal protective equipment. Those of us who work on high voltage equipment wear rubber gloves and check them for punctures, tears, or abrasions before starting any job. We also wear leather protectors over the gloves to protect the rubber. As important as wearing the right protection is, there's no substitute for following safe work procedures. Remember, failure to do both could result in electrical shock or burn, or you could even die.
As we said earlier, electricity takes the path of least resistance. The body's resistance to electric current is almost all in the skin, and the skin's resistance is reduced by water, which is a good conductor. That's why the 110-volt house current might give you a small jolt if you have dry hands, but can kill you if you have wet hands or feet. Rubber gloves, rubber-soled shoes, or a rubber mat can block an electrical path. Always use appropriate protection. Now, here's something else you should always take seriously, even though it may not sound like a very serious subject. Practice good housekeeping. Take a look at this work area and see if you can identify electrical hazards that have been created as a result of poor housekeeping. Be aware of the hazards that electricity can create in otherwise safe environments. For example, keep metal ladders away from electrical equipment. Never store flammable materials around electrical equipment in order to prevent explosion or fire. And don't leave spills on the floor. This could create a shock hazard. In addition, don't leave anything in contact with live power sources. This brings us to our final and most critical point: what to do in case of an electrical shock.
You're coloring that water.
Learn what to do in an emergency.
That was the ground water.
No, don't touch him.
Don't touch the victim until the power has been disconnected, or you'll get a shock too.
Shut the power off.
Know where and how to shut down the power in case of electrical shock. Know who to call for help, and be able to give exact information to emergency personnel.
There's been an electrical accident.
Administer first aid and/or CPR. If you aren't qualified to do so, find out now who is. Fortunately for this victim, his coworkers knew what to do to help. In many cases, the victim may be saved by quick action on your part. It's recommended that persons working on or near electrical equipment get training in artificial respiration and CPR. One excellent source of training is your local Red Cross. But remember, never touch the victim until the power has been turned off, or you'll become a part of the electrical circuit and receive a shock too. If you can't shut off the power, call maintenance or the electric company. Obviously, since electricity is such a big part of our lives, electrical hazards are a real and present danger. With that in mind, let's take a moment to quickly review the actions you can take to prevent the most common electrical hazards. After all, the more you know about electricity, the safer you and your coworkers will be. The first guideline in preventing electrical hazards is to inspect your work area. Be sure to choose the proper electrical cords and connectors for the job. Always read and follow instructions for proper use. Leave equipment repairs and adjustments to authorized personnel. Learn and follow required lockout-tagout procedures. Don't forget to use the appropriate protective equipment. Practice good housekeeping at all times. Know what to do in an emergency. Learn first aid procedures and precautions for assisting others. You've seen why it's so important to respect the power of electricity. So follow these rules at work and at home. Never second guess when it comes to electricity. Remember, electricity travels at the speed of light. So think before you act and treat every wire as if it were a live one.
Any questions about the film? I'll tell you how fast things can happen. When I was a kid, I walked down a gas station to see the man was working on my father's car. His hand was all bandaged up. 2 weeks later, he had a permanent wedding band in his hand. He had a gold ring on. He went to change the starter without disconnecting the battery, and he shorted out and melted the band on his finger. It was like an eighth of an inch deep. That's how fast it could happen with electricity. Around here, if you have a problem, like the film said, you're not qualified electrician. They go to school for 4 years, they do apprenticeship for the 4 years, they have to have a license. One of the most rigid construction tests is electrician license. Best thing you can do is just pull the plug. If you can't get to the plug, like the film said, you gotta know where the breakers are. And that's another thing for at home, when we go around and do inspections, what we do not find. The breaker box or the door should be marked for what breaker or fuse goes to what part of the house. If your dishwasher is on fire, starts a fire, you should know what breaker to use. It should be marked dishwasher, excuse me, the proper wire for that. Here, you should know where your breakers are for whatever room you're in. It's probably going to be a whole room. It's not going to be marked separately. Talking about extension cords, I haven't seen them in the hospital. I've seen them in a lot of commercial buildings. Like I said, they're older buildings. There's not enough outlets to go around, so they're running extension cords. You've probably seen them. They got duct tape all over the floor. It's no good. You're still going to step on it and wear it out. In your house, you should never run extension cords, especially under a rug. Because what's going to happen, you're going to forget it's there 3 or 4 years ago, and you're going to end up wearing the insulation off the wire, and you're going to have a fire. Remember what you need? Fuel. Direct current, material to the rug, fuel. You're going to have a fire. The best thing about electricity I found out is leave it alone, because I'm not an electrician. Don't touch it. You remember that rule, you should be safe. If you have to touch it, and you're not sure what you're doing, don't ask your friend sitting next to you working, because he or she's not an electrician either. Go ask somebody that knows. Get the electrician. You noticed the wire he touched was a white wire, and he got electrocuted? Okay, in that building, that's a ground wire. In your homes, that is not a ground wire. The white wire in your home is the positive side of the feed. The black is the negative. The wire in your boxes will be a bare copper wire coming out. Have no insulation on it at all. So if you're working, let's say, on a junction box and you don't have the breaker turned off, and you grab the white wire and touch the metal on the junction box, you just conducted electricity. It's going to go right through you. Just remember that. You can't go wrong. The white wire, 9 out of 10 times in a home, is the positive side. That's the one when you're touching that, you shouldn't be touching. If you are, you don't want to be in contact with water or anything that could grind you out. Okay. Does anybody have any questions about electricity at all? Anything? I mean, the film is really a good film. It really explains everything. It does, yes, ma'am.
So when there was something around the wire, is there any other way to get him away from that source, like
No.
wood?
Because really, the girl standing next to him, she could have been shot too, right through the floor.
If she had like these wires, something to smell the wire out of the sand?
Nope. Go to a breaker. You know, we have electrical wires go down in town here. Years ago, I don't know how these firemen did it. They used to take a pike pole with a handle and move the wire. You're talking 440 volts or whatever it is up there. That's going right through wood, too. Wood is not a good conductor, by the way, electricity. But at that power, it is. Because all that wire is, why it's popping all in the street is looking for a ground. And if you touch it, you become the ground. Like I said, the best rule is leave it alone. Definitely respect it like it said, but don't take it for granted like everybody does. Because people do. When things are fail-safe, as this usually is, nothing could ever go wrong. But that's not the way to look at it. You respect it, and I'm a little afraid of it, to tell the truth, I am. Because I'm not familiar with it. And electricians, they're, I don't know, I wouldn't like to have their job. They really do a lot of things, but they're around it 8 hours a day for years, so they know what to touch and what to do in the measures makers. I would not want the job, to tell the truth. Like I said, don't be afraid of it. It's a convenience. Use it.